crossbar that's going through the center of the circle would be our x and our y axis. The center of this circle would be the origin of our x and our y axis. And the initial side of any angle is always going in the positive direction on the x-axis. Tonight you're going to be graphing angles in standard position, which means the initial side starts here. Now, you can graph positive angles and you can graph negative angles. And the difference is simply which direction do you go in to graph the angle. A positive angle means that if I say graph a 45-degree angle, it means starting from this initial side, go up 45 degrees. Which would be this. That is a 45-degree angle. Now, if I said graph a negative 45-degree angle in standard position, you're still starting at this initial side here, but instead of going up 45 degrees, you're going down 45 degrees. So when you see positive and negative angles, that's the only thing that's the difference between them. You either go up from the initial side or you go down. If you were asked to graph a 200-degree angle in standard position, we said that 360 degrees is the degree measure of a circle, right? So when I have this crossbar going through it, that means that if this started off as 0 degrees, what is this here? It's 90 because it's 1/4 of the circle. And what's this here? It's half of the circle, which would be 180. And what's this here? 270 degrees. And if we went all the way back to the beginning, we would be at 360, correct? So if I told you to graph a positive 200-degree angle, that means if it's in standard position that it's going to start here at this initial side and go 200 degrees in the positive direction. So we're going all the way through 90, all the way through 180, and then how many more on this side? 200 degrees? How about another 20 degrees on this direction? Okay? Another 20 degrees in this direction would give you a 200-degree angle. Yes? Because of the direction that the angle is falling in. All right? Because if I have this line going in this direction, then it went in a positive direction. This is the initial side. You never start here. Okay? You always start from the initial side, and you follow through with this thing. So that is a positive 200-degree angle. Now, if you want to simply identify an angle by looking at it, whether it's positive or negative, does the blue or the green represent the positive angle? The green represents the positive angle because starting at the initial side, the green went in a positive direction. All right, so you're always going to start at this initial side. Even though I don't have an arrow, we start here and we went in this direction. The blue represents a negative angle because we start on the initial side and then where did it go? In a negative direction to get to this point. Okay? All right. Now, why do we need to convert from degrees to radians, and what's the difference between the two? When I say a degree measure, I'm talking about an angle. Okay, if I was to put a protractor up here and I said draw which this is not going to work too well, draw a 110 degree angle. Here would be your initial side, and you would go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, that's a 110 degree angle. Degrees is referring to this, and it's not a distance. You can't say, you know, here's a tape measure. Go take this stick and cut off 90 degrees. How do you measure 90 degrees with a tape measure? You can't. Okay, a degree is referring to an angle, or a, I don't know how else to say it, but it's an angle measure. Now, when we're talking about radians, we're talking about an actual physical length. Okay? Radians refer to, if I was to cut a string and lay it on that red line, how long is the string? Is it 5 inches long? Is it 10 inches long? Is it 12.8 inches long? Radian measure tells you an actual length. Okay? So, the first thing we need to do is understand what's the relationship between radians and degrees. Well, if we're talking about an actual physical length or distance around a circle, isn't that circumference? The circumference of a circle. All right? Now, if I said that the circumference of this circle is 4 feet. That means that you can measure out a 4 feet rope, string, whatever, 4 foot long. You could connect it here, lay it around the circle, and meet up here, and it's 4 feet long. All right? Now, when we're dealing with radians, we are asking us, what is equivalent to 90 degrees, but as a physical length instead for this circle? So what we're trying to figure out is, what portion of the circle are we talking about? If the distance around the entire circle is 4 feet, but I only want the distance around this much of the circle, Tyler, what portion of the circle am I talking about? 1/4, right? So if the entire circumference is 4, then the distance around this portion, or 90 degrees of the circle, is 1/4 of it. So when we are converting from degrees to radians, we are taking 90 of the 360 degrees and multiplying that by basically the circumference of the circle, because we're looking for a portion of the distance around the circle. Now, let's look at this. Yes, it'd be a good idea. Now, just get the main ones. Get these.
It's in the book.
Yeah, it is. Okay. Now, forgetting about multiplying by the radius of a circle, because the only thing that's going to change when you're doing this is the sizes of circles, which is the radius. So now we're just going to focus on the degree and the actual radian that are related to each other. Let's see why. Now, this means that you've gone all the way around and come back. Let's see why this is 2 pi. Okay, well, if the circumference of a whole circle is 2 pi times radius, and I just said we're not going to worry about the actual radius measured, then a whole circle is 2 pi, correct? What portion of a circle is 360 degrees? It's the whole thing. So